Symmetry is a quality of an object giving balance or similarity. In math, function symmetry means that a function has some kind of balance or similarity, perhaps a reflection of itself or a rotation of itself. Knowing that a function has a certain symmetry allows us to draw conclusions about unknown parts of the function based on known parts. We will look at two types of function symmetry called even and odd. Visually or graphically, even function symmetry means that the function's graph is a reflection of itself across the y-axis. If you were to flip the graph left and right with the y-axis as the reflecting line, you would see the same graph after the reflection. This is illustrated in the animations below. Looking at the numbers representing x values and their corresponding y values, in other words numerically, we see that even functions have the same y values when we compare opposite x values, the y values being the height of the graph and the x values being the horizontal distance from the origin. In a table, opposite x values have the same y values. This is shown with matching colors in the table you see on the screen. At x equals 0, the y value can be anything or even undefined. In symbols, or algebraically, even functions have the property f of x equals f of minus x, which means that f of x, which is the y value for the given x value, is the same as f of minus x, which is the y value for the opposite of the given x value. This allows us to do the math to see if a function has even symmetry or not by setting up the equation above, writing expressions for f of x and f of minus x, then simplifying and seeing if they are equal. If they are equal, the function is even. If they are not equal, the function is not even. Note that it is not necessarily odd in this case. We have to test for that separately. The example even function that we have been looking at has a function expression of f of x equals x squared plus 1. Let's see how to test this algebraically for even symmetry. We'll start with the definition, f of x equals f of minus x. On the left we have f of x, x squared plus 1. On the right we have the same thing with minus x replacing x. I've written this out with minus x squared shown as minus x times minus x. And when we simplify that, we see that we have x squared plus 1 on both sides of the equation, which makes the equation true, so the function is even. Visually or graphically, odd function symmetry means that the function's graph is a 180-degree rotation of itself around the origin. If you were to turn the graph 180 degrees with the origin as the center of rotation, you would see the same graph after the rotation. This is illustrated in the animations below. Another way to visualize the graph of an odd function is that it is a reflection over the y-axis followed by a second reflection over the x-axis. This is illustrated in the animations below. Looking at the numbers representing x values and their corresponding y values, in other words numerically, we see that odd functions have opposite y values, or heights of the graph, when we compare opposite x values, the horizontal distances from the origin. In a table, opposite x values have opposite y values. This is shown with matching colors in the table you see on the screen. At x equals 0, the y value must be 0 or must be undefined. In symbols, or algebraically, odd functions have the property f of x equals negative f of minus x. This means that f of x, the y value for the given x value, is the opposite of f of minus x. This is the opposite of the y value for the opposite of the given x value. This is also sometimes written as negative f of x equals f of negative x. Again, this allows us to do the math to see if a function has odd symmetry or not by setting up the equation above, writing expressions for f of x and minus f of minus x, then simplifying and seeing if they are equal. If they are equal, the function is odd. If they are not equal, the function is not odd. Note that it is not necessarily even. We have to test for that separately. The example odd function we have been looking at has a function expression of f of x equals 1/10 x cubed. Let's see how to test this algebraically for odd symmetry. We start with the definition of odd symmetry. F of x equals negative f of minus x. On the left we have our original f of x expression. On the right we've replaced x with negative x and put a minus sign in front of the whole function. And the next step, I'm breaking down negative x cubed into negative x times negative x times negative x. And then we see that we have one negative sign from the original definition, which is shown in purple, and we have another negative sign from the three negatives multiplied together, which is shown in red. Those two negatives form a positive, and so both sides are equal, making the equation true, so the function is odd. Even though we now know that this function is odd, let's apply the even test to the odd function to see why it is not even. So we start with the definition of an even function, substitute the values into the equation, simplify, and we see that on the left we have positive 1/10 x cubed, and on the right we have negative 1/10 x cubed. These are not equal, the equation is false, so the function is not even. In a similar way, we can apply the odd test to our even function, f of x equals x squared plus 1, to verify that it is not odd. Start with the definition of odd, substitute values, simplify. On the left we have our original function x squared plus 1. On the right we have negative x squared plus 1. This equation is false, so the function is not odd. Graphically testing a non-odd function to see if it has odd symmetry involves a 180-degree rotation. We can see that this test fails. We can also think of this as a reflection over the y-axis followed by a reflection over the x-axis. We can see that this test fails as well. If we graphically test a non-even function for even symmetry, we can see that the reflection across the y-axis fails. In summary then, even functions and odd functions can be compared graphically, where an even function is a reflection over the y-axis, and an odd function is either thought of as a 180-degree rotation around the origin or a reflection over the y-axis followed by a reflection over the x-axis. Numerically, in a table, we will have the same y values for opposite x values in an even function, whereas we would have opposite y values for opposite x values in an odd function. And algebraically, we would use the test for an even function to see whether f of x equals f of negative x. If that's true, the function is even. If it's not true, the function is not even. If we test for odd symmetry, we want to set up f of x equals negative f of minus x, test to see whether that is true. If it is true, the function is odd. If it's not, the function is not odd. Notice we can apply an alternative test, which is basically the same equation with the negative side moved to the other side. Negative f of x equals f of negative x.